Hello everyone, today we are talking about doing the second data on the box plot. View a little and then moving on to the new stuff. The meaning of the box plots that describe the distribution without outliers. And that's what we did last time. And you guys are really good at getting the find number summary and plot your box plot. Couple other things I want to talk about. A box plot that describes a distribution without outliers consists of 4 parts. Now don't forget again, make sure you write down all the rest stuff because that's supposed to be the blank line you fill out for your note sheet. The left whiskers, which is you guys know, the left part of the box, the right part of the box, and the right whiskers. So if you remember, the whiskers look like this is the whiskers, there's the box, and then there's another whiskers. Okay, so that is the box plot. Each part represent approximately 25% of the observation, and you guys know that. From median to Q1 is 25%. From Q1 to Q2, or the median, is going to be 25%. From the median, which is Q2 to Q3, that's another 25%. And from the last part, which is Q3 to the maximum, that's also 25%. And then we also talk about it, that the full length of the box is equal to the IQR. And again, quick reminder, IQR is going to be Q3 minus the Q1. And that's just a quick reminder. So next one, the following 2 statements apply to unimodel distribution. That means just one hump, okay, one peak. So in this case, if the left part of the box is at least as long as the right part of the box, and the left whisker is quite a bit longer, left whiskers longer, and then the right whisker, left whiskers is longer than the right whiskers, then the distribution is skew left. So the only reason I only color the red part is if you have left whisker longer, you skews left. That's why I want you to remember left and left. And the next part is if the right part of the box is at least as long as the left part and the right whiskers is longer, then the left side, right, is longer than the left, then skew to the right. So it's right, skew to the right, right whisker longer, skew to the right. Left whisker is longer, skew to the left. That's why I want to only color those kind of things so you don't get confused with everything all mixed together. First example, we're gonna talk about the box plot, and then from whatever the information I just gave you, we're gonna apply to the problems. Okay, example 1. The jump height in centimeters of 40 college soccer players are described by the box plot. Okay, and so right there is the box plot. Number 1, the distribution of jump height. Symmetrical, skew to the left, skew to the right. Pause, check, write down your answer and check with mine. The skew to the right. And because the right whisker is longer, you can definitely see this part is longer than this part. So therefore, the right whiskers is longer, skew to the right. Next question, it says, estimate the range of the jump height. What does it mean in this situation? It's kind of approximation. So for me to approximate, I would say the maximum is about 71 because a little bit more than 70. And how about the minimum? The minimum is going to be about maybe 33. So in this case, the range you should know is the biggest max minus min. So range is going to be 71 minus 33, and therefore that is going to be 38. And what does that mean in this case? Well, it means all the jump height are within 38 centimeters of each other. So the next one, number 3, estimate the IQR. What does it mean in this situation? Well, don't forget, IQR is Q3 minus Q1, and that's equal to IQR. So when you do that, you are going to say Q3, I'm gonna see it's probably by approximation, I will say about 58. Let's take a look. Yeah, see there's the 60, and then that's not quite 60 right here. Okay, and then the minimum is going to be right here. And then that's a little bit like right on the line kind of. So I would say Q1 is going to be 40. And IQR is going to be 58 minus 40. So that's equal to 18. And what does that 18 mean? This means that about 50% of the jump height, 50% of the jump height is within 18 centimeters of each other. Forgot to add the middle 50% of the jump height is within 18 centimeters of each other. Hope you guys can answer those kind of questions. If you have any question, please let me know. Now, next one. Next definition is fence. Now, what is fence? Well, we talk about box plot that has no special numbers. It's within the max and the min and the box in the middle. So now fence tells you the left fence and the right fence have some data value are given by. Those are the ones that might have a little bit too far away. So in this case, there's a special name for them. But there's also a formula to calculate. So the fence, it says the left fence and the right fence of some data value are given by left fence. Okay, so that means if the number gets even smaller. So that's Q1, which is at the 25%, minus 1.5 times the IQR. And the right fence means the number gets bigger, means Q3 plus 1.5 times the IQR. Those are the formula. Please jot it down. Okay, and then we're going to do a problem, and then I can show you how that is done. Example 2, student in one of the author's statistics class were surveyed about the number of hours they study per week for the course. Here are the anonymous response of 10 of the students. Okay, now we done this problem before, so I'm going to just fill in the numbers, and then you can double check and see did you have the right numbers like mine. Okay, we have Q1 is 4, Q3 is 10, and the IQR is going to be Q3 minus Q1, and that's why it's going to be 6. Okay, that's IQR. Now, the next part is, how do you calculate left fence? All right, left fence formula goes like this. Q1 minus 1.5 times IQR. And so in this case, we have, because think about it, if this is the box plot, just a freehand, okay, your left fence is going to be right here. Those are your left fence. all right? And then this part right here is going to be your right fence. Right? So it's going to be further out. So let's take a look at the numbers. So the Q1 is going to be 4 minus 1.5 times IQR, which is in this case 6. Or you can just put a parenthesis in there. So in this case, if you punch in the calculator, all right, now don't forget, order of operation gets done first. So it's going to be 1.5 times 6 first. And that is going to be F4 minus 9. And that's going to be a negative 5. Don't panic. It's okay to get those numbers. And the right fence, I would like you guys to try it and see, do you get the same number like I do? The right fence is going to be Q3, which is 10, plus 1.5 times 6. And 1.5 times 6 is 9, so that will be 10 plus 9 equals 19. That means the left fence from here, let's actually make this purple, so that will be a little bit more helpful for you guys. It's right here, that's the purple part. It's going to go down to 19 is going to be the right fence. And then the left fence is going to go down this way. And that's going to be going down to negative 5. Okay, so this is going to be the left fence, sorry. And this is going to be the right fence. Now, why is those numbers important? Well, the reason those numbers are important is we are going to talk about outliers, which is we heard about it so much. So now that we have a technical way of trying to identify them. So a data value that is less than the left fence or greater than the right fence, we say that the outlier lies outside the fence. So that's why it's important. So anything outside of that is very extreme data. Okay? So that's why it's kind of important to know how to calculate the right fence and left fence. And that's beyond the maximum and min. Okay? So any other data that's outside of those kind of consideration, that's going to be very, very kind of tricky. Now, sometimes those numbers will be smaller than the max, or some of the numbers will be really out there. So we need to be careful on those kind of situations. So here we go. A student, example number 3. Student in one of the author's statistics class were surveyed about the number of novels they read in past year. Here are the anonymous response in numbers of novels. Of 11 of the students, they read 2 novels, 5, 2, 0, 2, 3, 0, 5, 6, 4, and 12. So I would like you guys to answer some of the questions and then at least up to left fence and right fence and see can you guys get it. There are the answers for example number 3. If you have anything that you don't understand how to get them, any reason that you can't get them, please let me know tomorrow or the next time when we meet and make a note of it. I'll be happy to go over it with you. Okay, now construct a box plot. I'm going to pause it because I just want to make sure that you guys know how to do it and you can double check your answer. Now, here is the tricky part. You come down here, you say, Miss Weisman, my right fence is at 9.5, but I have a piece of data that's the maximum that tells me is 12. Now you told me anything bigger than 9.5 is going to be an outlier. So where should I draw my maximum? Okay, this is where the tricky part. So if you look at your data and if you put them in order, the number of the data is going to be 0, 0, 2, 2, 2, 3, 4, 5, 5, 6, and 12. And we know the 12 right here is too big compared to the 9.5. So therefore, we cannot include that 12 in our box plot. Let me say again. Because 12 is bigger than my red fence, I cannot include that in my box plot. So what do I do? So what we're going to do now is we are going to grab the next biggest number. And that is why it's very important to put your number in order. Okay, so now the next number is going to be where your tail is going to end. So in this case, 6 is going to be your tail. And going down to the other side now, my left fence is negative 2.5. So if I have it at 0, I will be okay. So therefore, I'm going to stop at 0. And there is my box plot. And then we are going to take our little outlier and put it at where the 12 is. And that is your outlier. I hope that makes sense. D, what is the meaning of the outlier? Well, the meaning of the outlier in this case is the outlier 12 novels means that the students read many more novels in the past year than the other 10 students. I'm going to write it down and then you guys can read it. Okay, so now example 4. Check out outliers in the following data set of waiting time. Data set A. All right, so I would like you guys to give it a try one more time and see can you guys figure it out. Pause it and then I'll show you the answer after you start the video again. So I want to talk about example number 4. I want you guys to notice that first I put things in order. Okay, and I also calculate my Q1, Q3, and IQR. You can do it by calculator or you can do it by hand. If you want to do by calculator, you can add them together, divide by how many is there. That will give you the 6.6. And to calculate your IQR, you can also cut in half because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you have 10 of them, you can cut right here. And then therefore, looking at the lower one, this is going to be your Q1. And right here, this 7 is going to be your Q3. And your medium is going to be between the two that's got in cut half, but they don't have a number in the middle. So therefore, you are going to combine the two right in here. And if you add them together, which is 5 plus 6, divide by 2, and that's going to be your 5.5. Okay? So now, what you have also is a calculation of your lower fence. Now, lower fence also is another word for the left fence. They mean the same thing. And the upper fence also means the right fence. They means the same thing again. So now what you're going to do is, if you look at it, and then if you imagine when you construct your box plot. Oh, I'm sorry. Yeah, your box plot. Box plot. Your smallest number will be 2, and your biggest number is actually 8 on your on the whiskers. And 20 is an outlier because 20 is past 10. So make sure you understand that. If you don't understand that, you gotta let me know the next time we meet. So 20 is an outlier. Okay. Next part. Compare mean and median. Which summary statistic is better suited for the data set and why? The reason it is going to be the median is because the median is better measured of the center than the mean for a skewed distribution. Now, how do I know this is a skewed distribution then? Well, it's because 20 is an outlier. That means the number is going to pull away on the right-hand side. So what kind of skew is it? Well, it's going to be skewed to the right because there's the whisker is going to get extended very long from there. Okay? I'm going to write it down. Okay, we are going to skip here's the answer for compare mean and median. But the next part is which summary statistics. That question is just the same thing as the one above. So we are going to skip that. So please cross that one out. Sorry about the problem. Then the next part we're going to talk about is the z-score. Now z-score is very interesting. Z-score is actually giving you a median and give you a piece of data. So that means a piece of data that you have. And you are trying to figure out how many standard deviation is that piece of data away from the median. Okay? And that's called the z-score. So in this case, definition of it is a number that measures the number of standard deviation, an individual piece of data, individual data point, is away from its mean. Okay? And then we're going to write down the symbols. So I will stop talking. Okay, so just to really quick cap about what the symbol I just put down. Z is stand for the z-score, how many standard deviation away. We are talking about samples because talking about population gets a little bit crazy. The number is a little bit harder to digest and understand. So in this case, we're going to talk about the individual. So X is stand for individual piece of data. X bar means the mean, which is adding all the data together, divided by how many is there. S stands for standard deviation. Okay, so in this case, the symbol and the formula for the bottom is if you do a crisscross multiply and move the X bar, you can get the formula. And then in this case, you can see this is the individual piece of data. How do you find individual piece of data if you are given standard deviation, your z-score, and times what's the mean? Okay? Oh, I'm sorry, plus whatever is the mean. All right, so couple things we are going to talk about. Z-score are unitless. They just tell you how many places away from standard deviation, which makes them great for compare value. Okay. Will second bullet says, will the z-score be positive or negative if the data point is above the mean? That is going to be positive. And below the mean, and that's going to be negative. So in this case, if it's above it, you're going to know it's going to be between 50% to 100%, 100 that way. or anything that's below, you're going to go below the mean. Okay, so that in that case it is towards the 0 to 50% or even lower, depends on how far the standard deviation. It could be an outlier too. Next one, z-score are sometimes called the standardizer value. Next one, z-score gives us a way to compare value that is measured in different variables, different units, or are from different populations. Again, we are only talking about samples here. Z-score can also be used to identify unusual values in a data set. And in this case, if they are 4 or 5 standard deviation, you know that's unusual data, and therefore it's going to be an outlier, because most of our data set falls into with 3 standard deviation away. Student A scored 95 points on an exam where the mean was 77 points. And the standard deviation was 10 points. Student B scored 88 points on the exam where the average score is 75 points on the standard deviation was 5. So in this case, you guys can understand, what are we comparing? We have 2 different situations. We have probably 2 different set of classes. Ms. Wiesman have data modeling class. How can I compare how far is each piece of data away from each other? So in this case, which student did better? So now what we're going to do is we're going to write down the standard deviation. So the formula goes like Z equals the piece of data minus the average over the standard deviation. So if you do the problems, the student A has the z-score. Let's write it this way. The z-score of a student A is going to be the piece of data, which is going to be 95 minus standard deviation, or the mean, the mean is 77 over the standard deviation, which is 10. Okay, work it out. My z-score for student A is 1.8. Notice the points and the points, top units, bottom units, they cancel out. They just give you a range of 1.8. So that means student A score is 1 plus 0.8 standard deviation away from the mean. Okay. You try student B. Okay, so I got 2.6 for z-score for the B student. All right, now which student does better relative to the perspective of the class? Well, I will go with student B because he's 2 standard deviation away from the mean. That means his score is much better than everybody else in the mean. So therefore, student B did better. The standard deviation, the z-score is higher, so therefore it is better. For which student did better relative to their prospective class? Explain. Well, student B definitely do better because his z-score is higher, and higher is better on an exam because that means he's further away from the mean. And then since it's a plus, he's definitely doing better than the mean, which is the rest of the students.
'Cause 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 'cause
most of the students. Okay, so a couple notes. Bigger is not always better. Let me start again. Bigger is not always better. Comparing times to complete a task, the small number would be better. Well, the reason for that is because that takes less time. Compared to company's product and want some measurement to be particular value, then a z-score near 0 is the best. So it depends on the situation. You have to think about standard deviation. Is it further away better sometimes or closer better? Okay, so be careful when you answering question, thinking about what they are asking. So example 6, a test paper without name on it score 80%. The morning class has a mean of 72% with a standard deviation of 3%, and the afternoon class has a mean of 92% with a standard deviation of 7%. Which class is the test paper more typical of? Explain your answer. Well, let's try to figure out the z-scores. Working out the numbers on the z-score. That means that morning is 2.67 and afternoon is negative 1.71. Now, negative doesn't mean it's a bad number. It just says I'm on the left-hand side of your mean and I'm 1.71 standard deviation away. And the 2.67 is on the right-hand side, which is positive. That's why it's positive. And that is 2.67 standard deviation away. So which one did you think is more typical? Well, I will probably go with the afternoon because it's closer to the mean. So that will probably belong to the afternoon class because it's closer standard deviation. How many standard deviation away? So okay. B, morning or afternoon? Because, well, it's definitely afternoon because we have a closer to a 0 z-score, and that's why afternoon class tells you. Even though it's negative 1.71, that means it's still closer in the distance wise. Okay, so B is going to be z-score is closer to 0, which means that the score is closer to the average for that class. C, do you think that z-scores are resistant? Resistant means it doesn't move that much. Why or why not? Well, z-score is not resistant. And the reason for that is because if the mean is based on the mean, so mean is the average. So if you have a really, really huge average, because you have a one piece of data that does not really fall into the norm, then you are going to change your z-score. So that's the reason, and I'm going to write it down for you. Okay, so that's what I put down for C. C says, do you think that z-score are resistant? No, z-score are not resistant. They use means and standard deviation that are not resistant. Okay, next one, second kind, interpret percentiles. Okay, definition of kth percentile. The value below which k% of the data observation falls. Notation for the kth percentile is P. You use a big P, stand for percentile, and K. That's the percentage. So k% of the data falls at or below the kth percentile. And 100 minus k% of the data falls above the percentile, above the kth percentile. Since 50% of the data sets fall below the median is at the 50 percentile. And percentile are resistant. That means it doesn't change a lot because that's almost like the medium right there. Okay, a medium 50 is still the 50th data. It doesn't matter what is the number is related to. It's just the 50th position. So the number can change, but the position does not change. Example 7. The scores for the typical standard exam has a bell-shaped distribution. That means it's just a nice even peak. Okay, what would it mean for a student scores in the 50th percentile for such a distribution score? Well, 50 percentiles right in the middle, so the student score, the mean, and mean is the 50 percentile equals medium. For the mean equals medium in this case because it's a bell shape. And for this student, the student is at 50th percentile. Okay, next one. The height of the student is in the 90th percentile, while their weight is in the 10th percentile. Explain what each of this percentile means individually. What do they tell you about what the child looks like? Well, 90% of the 90% of the kids are shorter than he is, so he's really tall. And then 10% of the kids weighs less than he does, so he is really skinny because only 10%. So 10% is on the lower end. So in this case, this child is really tall and really skinny. Well, this concludes the 4.3 box plot, the wrapping up of the second days about the difference between outliers, the percentile, and how to figure out what is an outlier. Okay, if you have any question, please let me know. Thank you for watching.